Hi, my name is Kendra Sweet. This is my solved combined spectral problem from Organic Chemistry Week 8. Starting out, we were given 3 spectra and the molecular formula C9H12. Starting off, I determined degrees of unsaturation via the molecular formula and the DU formula seen on the slide here. My calculations resulted in 4 degrees of unsaturation. When analyzing the IR spectrum, starting over on the left, we can see this peak around 3020 to 3100. Those medium peaks represent the carbon-carbon double bond stretching vibrations. At 2975 to 2845, these strong peaks represent carbon to hydrogen stretching vibrations. These weak peaks at the top, around 1650 to 1500, represent carbon single bonds of a aromatic ring. And then over here we have some medium peaks at 1640 to 1680, and those are some standard carbon-carbon single bond peaks. Looking at the hydrogen NMR peaks, the spectra we were given, we can assume that the integrated intensities of the hydrogen NMR chemical shifts give the ratio of the protons in the different non-equivalent environments of the molecule. You can see here that the integrated proton ratio is 5 to 2 to 2 to 3. Starting on the left, this chemical shift at 7.5, that represents the aromatic proton resonance. Over here, we have the methylene group nearest the benzene ring. And then we have another peak over here. 1.5 ppm, that resonance is from the second side chain methylene. It is split into a sextet by the neighboring methylene and methyl group. And then lastly over here we have this 1.0 shift, 1.0 ppm, which comes from the side chain methyl group. For our carbon peaks, we actually have 7 different chemical shift lines due to 7 different chemical environments. On the left, our peaks downfield due to the sp2 orbitals found in the benzene ring carbons. We can see that we have 1 peak, 2 peaks overlapped, and then 1 peak here. And those are represented on the bottom of this chart, 143 ppm, 128, 128, and 125 ppm. There are 4 different chemical environments in the ring. 2 overlap because they are similar. Or the same, I should say. Upfield, we have 3 peaks representing the methylene-methyl group chain attached to the benzene ring. My suggested structure for this project is propylbenzene, I believe it is a 6 double bonded carbon ring, benzene, with a 3 carbon substituent group, due to the peaks seen in the spectra provided. Thank you.